Welcome to another Excel VBA Fun with Games. We're going to look at building a snake game, which is incredibly similar to the Nokia Nibbles game. This game utilises a user32 library API call to get user feedback from the keyboard. It also adjusts the keyboard behaviour for the arrow keys using onKeys. There is a game timer which defines the speed of the game. Effectively, it's kind of like a game engine. And that, in combination with the input from the user, really kind of defines the game. The user interface is through conditional formatting, and that's the game in a nutshell, really. Let's go and see how the game plays, and then we'll have a look at the coding. Playing the snake game. This is similar to the Nibbles game found on the old Nokia phones. This mainly uses conditional formatting within Excel to produce the graphics and the gameplay area. The speed, acceleration and growth is set by the user and can be adjusted before the user starts playing the game. Feedback to the user is which level they're on and their score. It also carries the high score of the game so far. You capture the mouse 10 times and then you level up to the next level. Just before each level starts, the user gets a notification that the level is about to start. The game is over when the snake either hits the boundary, an object, or itself. All the levels are user defined, so you can create as many levels as you wish, or as few as you wish. Once the player reaches the last level, that level will keep replaying until the user crashes into itself, a boundary, or an object. The boundaries are red, the objects are yellow, and as we can see, the snake is green. Later on, we're going to have a look and see how the user interface was built, the flow of information around the game, and the code that made the game. I hope you enjoy this and you get as many hours of fun out of it as I've had building it. Building the user interface. First off, we'll start with the snake sheet, and next we'll set the column widths and the row heights. This game is mainly built from conditional formatting. We give the outer border the value of 2 and then we conditional format that outer border. Any objects for the snake to move around within the gameplay area, we give a value of 3, and again we add conditional formatting to that. As we can see here, we're giving the border the colour red, and we're giving objects a colour yellow. The mouse will be pink and the snake will be green. The background of the gameplay area will be light blue. Next we're going to create the game templates sheet, and this is where we keep each level of the game. We start off by copying the game area that we've already created. We paste it to the game sheet. We format the cells, and then we make the game area a named range. And the format of the named range is end game and the number of the level that that template represents. To paste it into the game area, we create a named range called end game paste, and we use that to copy and paste from games to snake. Now we're going to create the title. Next we'll add some images we downloaded from the internet. We have to make the background invisible, so to speak. Once we've formatted this image, we'll take a copy and then we'll reverse the image. Next we'll add the button for a new game, and we'll use insert shape. Later we'll assign a macro to this button. And now we're going to add some information for the user, such as which level they're at, what their score is, and what the high score is for the game. And we also make these named ranges. If you'll notice that all the named ranges that have been created, they all start with lowercase n, and this makes it easier to notice the named range within the code. Next, we're going to add a title for the game variables that the user can set. And now we're going to add the labels for speed, acceleration and growth. Next, we add in the user input fields for speed, acceleration and growth. We'll also make these named ranges. Next, we're going to add comments so the user knows what to put in there. And to help control the values that the user inputs into these fields, we're going to use data validation. Next, we're going to create the game notification, and this is the notification that we give the user before the game starts. Here we'd forgotten to set the mouse up for conditional formatting. Now we're going to show keyboard arrow keys to give the user an idea of how to play the game. Now we're going to set the background of the game to an image we downloaded from the internet, and we're going to remove the headings, grid lines and formula bar and hide the menus. And that's our user interface.
Firstly, when looking at the game, we need to have a look at the user interface and the parameters. The user sets the speed, and the speed is the speed at which the game engine runs. Next, the user changes the acceleration, and the acceleration is the increase in speed when the snake eats a mouse. Lastly, growth is the amount the snake grows each time it eats a mouse, and these are all user defined. Feedback to the user is which level they're on, what their score is, and what the game high score is. The user sets the game high score after the game has been played. They've either achieved the high score or not. The game is initiated by the new game button. Game design flow. This is the flow of logic within the code and how the game has been set up. The user interface has parameters for speed, acceleration, and growth, as we saw previously. These parameters are used when the game is initiated via the new game button. The initiate game process sets the parameters. It gets those parameters changed by the user. It also resets the game level and score, 1 and 0 respectively. It also calls a new level subprocedure. This new level subprocedure is called every time we need to change a level in the game. Initially, it's set to level 1. The user gets shown a notification for the start of the level. The snake and the mouse is shown, and the game loop starts. That's the initiation process. The game loop is entered by gameplay, and the gameplay is a continuous loop that calls move snake subprocedure and calls game timer subprocedure. And these two subprocedures are the game logic and the game engine. Move snake contains the logic of the game. We set the direction of travel and we increment that movement by 1. Once moved, we then test for a snake collision. That's, does it hit itself, an obstacle, or the boundary? If it does, we initiate the exit game loop process. We also test for high score. If applicable, we update the high score. The next test is for mouse capture. If we capture a mouse, we count the amount of times the mouse is captured. In this case, 10 times, and we move to a new level. This process also initiates a new level if required. Else, previous 2 tests have failed, then the game is still being played, and so we continue the snake movement. That's the logic of the game. What we also do within the gameplay loop, we initiate the game timer, and the game timer sets the speed for the game. Each time the game timer loop goes round, it tests against the speed with which we set the game. The game timer allows the user to interact with the game via the keyboard. It also passes the keyboard interaction to the game logic. This is done through a set of keyboard parameters. We use the onKeys to override the default behaviour of the arrow keys that we wish to use to make the snake move. A subprocedure then updates the variables for the snake direction, which in turn allows the game logic to determine the direction of travel and increments by 1, and so the loop continues. So in this case, what happens is the user changes the user parameters if they desire to. We initiate the game by resetting the levels to 1 and score to 0. We start the game, and then the game loop starts. And the game loop is a continuous loop until we tell it that the game is over. And we only know if the game's over is through the game logic in Move Snake. Now, Move Snake needs to know in which direction to travel, and that's done through the game timer. And the game timer uses the interaction with the keyboard to pass on the onKey procedure to the game logic. This continual circle of gameplay calling move snake, game timer, user interaction defines the game. And that's the game in a nutshell, really. It is quite a simple game. It's all the add-ons that we add to it that make it a little more interesting. Let's take a look at the coding behind the game now. Let's start with how we get the user to interact with the game. Now, whilst the code is running, we cannot accept user interaction. If we go over to a module that's been named MDL timer key state, and here what we do is we use user32 to get async key state, and each key state has a value. And what we're using here are the arrow keys, and we can see that vk_left equals h25. These values have been looked up on the internet. First off, we make an API call to user32 to get async key state, and then we apply which key values we want to use. Actually, what might be better is if I isolate the code. So click here to isolate the code. Declarations, we have an API call. Gameplay, this is the game loop. And here we have a global variable be on off, which is set to true. And this is used to control this loop down here. Initially, we set it to true to enable the loop to run. And all the time that be on off is true, this loop, game loop, will run. If we want to stop that game loop, we set be on off to false. And that's how we control the animation in the gameplay. This loop only calls two functions. It calls moveSnake and it calls gameTimer. And gameTimer is given a value, a double value. And we can see here in the comments, continuously loops through the game activity, moving the snake and taking in user actions as part of the gameTimer. What we'll now do is we'll move over to gameTimer, which is the second call in this loop. And gameTimer allows us to get user interaction. And we can see from the comments here that sets the speed of the game based on a double delay time parameter, allows for user interaction while the macro is running. So we have a variable here, time start, and time start equals timer, and this is the point at which we enter this sub-procedure. So we set our start time. The double timer says how long to delay this time, and so we say timer plus double timer equals the time at which we delay. And the delay is we have a number of loops or iterations through these loops until timer minus start time is equal or greater to delay time, and that gives us our speed. So the shorter delay time is, the faster the loop will run, in as far as the loop will have either more or less iterations based on the time delay that we've given it, but the code will be held up at this point based on the delay time that we give it. We made an API call to user32, and here we pass arrow key press to onKey behaviour. Now we'll go on to onKey behaviour in a moment, but this is the point at which we get windows to tell Excel whether a key has been pressed, and in this case the keys that we defined. So we've got VK left, VK right, VK up, VK down, and we can see next to them is then we've got press left, press right, press up, press down, and these are sub-procedures defined on the onKey process. The next piece of code in here is really important, especially for gameplay if you want some kind of user interaction, and it's do events, and this enables the user to interact with Excel while the code is running. Otherwise, the user would not be able to interact with Excel. This timer key state is essential for gameplay. This is part of the game engine. This gives us the game cycle, the game speed. Now moveSnake we'll go on to in a minute, but we'll just have a look at onKeys. So if we go to module onKeys, reduce this a little bit. Declarations, all we have is some notes up here. Using Excel onKeys allows us to override the default key behavior. In this case, the arrow keys no longer move the cursor around the screen and highlight the cells. Now this is important to us, is if we move the arrow keys and the arrow keys also move the cursor around the screen, it means our cell highlighting would be activated, and so we would be moving from one cell to another over the screen when we wish to move the snake. So one of the consequences of this behavior is we stop that behavior happening and we give it a new behavior. Declare onKeys. This is a sub-procedure onKeys, defining the onKeys, pointing to a separate sub for each key. Sub overrides default behavior. That's as discussed earlier. So we say application onKey, and we use curly brackets with up inside, and you can see down each one of these represents an arrow movement. So we define the arrow movement, which key is going to be pressed, and then we say which sub-procedure is going to be run. And in this case, for an onKey statement, we need to wrap the sub-procedure in quotes. So what this does is this tells Excel that we have a different behavior for that key press. The previous call to the API user32, that told us when that key press happened. The next stage is to tell us what to do once that key is pressed. So if we say key press down, we can see we have some comments, design build comments, while I was building this process. This is I used these bits of code to help me design it, and then once I'd finished with them, I commented them out, and now I'm just left with an if statement. So this is saying that if we press the arrow key down, if string direction, which is a global variable, does not equal u, then string direction global variable will equal d. That d will define the direction of movement for that key press. Now if we look at all the others, we can see that left, where they're saying if it's R, it does not equal R, then string direction will equal L, and so on. And we do this for each one and press up. And so all we're defining here is the direction of travel for the snake, nothing else. We're not defining the movement, we're just saying which direction we wish the snake to move in. Finally, we've got reset onKeys. Now one of the things about onKeys is once we've set onKeys, we have to cancel that behavior. Otherwise, whenever we open an Excel, if we open an Excel workbook afterwards, the arrow keys will still have the behavior that we've given them. And we can see here, the onKeys need to be reset to the default behavior, or each subsequent workbook will have this key behavior. Call this on exiting the workbook. So that's one of the things we do, is we call this sub-procedure on exiting the workbook. And we can see here the application onKey, which key it is. And the difference here is we don't define a sub-procedure. We omit that part of the statement, and that resets the key to the default behavior. And we can see that this workbook before close, and we call reset onKeys. So at the point at which we exit this workbook, we're resetting the onKeys. And that is the key behavior and how we define the key behavior within the workbook. Now the next thing that we had in the module timer key state was move snake, and move snake contains the logic of the game. So if we go to module snake and we take this to just individual procedure view and we go to move snake, we can see that this here is the logic of our game. Now the first thing we do is we calculate the direction of travel for the snake, and this is based on the onKey sub-procedures that we saw earlier, and they update the value in string direction. And we can see here that we say calculate the snake's direction of travel set by onKeys except on rebirth. Now what this means is when the snake is reborn or shown to the user, that will be a random process as opposed to this. We have a select case. If string direction is U, then we're going to say that R equals R minus 1. Case is D for down, then we're going to say R equals R plus 1. So these are rows, so we're going to either say minus 1 to go up the screen or plus 1 to go down the screen. If it's case R, then we're going to say C equals C plus 1, or if it's L, we're going to say C equals C minus 1. So these are columns. So we're going to say if we want to move right, we're going to say whatever the column we're in plus the next column is we'll move 1. And likewise, if we want to move less, we minus a column. And that's how we move the head of the snake. The way in which we deal with calculating the snake is we put the cell values in a collection. Once we've gone through this select case, we then go to our collection and we add the address of cells R and T, and we add that to the top of the collection. The next thing we need to do is define the behavior of the snake. We need to know when the snake has run into itself, collided with an object or the boundary. And we can see here that we've got some notes. This is another case select, and it defines the results of the snake's movement. Case 1 tests for a collision, case 2 tests for a mouse capture, and case else continues the game. That means that if case 1 or 2 is not true, then the game must be in play. With our select case, we want to know what the cell value is. So our cell value will either be -1, which is the snake itself, will either be 2, which is a boundary, or it will be 3, which is an object. When we calculate the head of the snake, we say, right, okay, is the head of the snake going to be on a cell value of 1, 2, or 3? And we can kind of have a look at that. So if we go and have a look at the user interface, if we select one of the objects, we can see that it's given a value of 3. If we select border cells, we can see that's given a value of 2. If we select the snake itself, we can see that this is given a value of -1. The mouse is given a value of 1. So we're saying if the snake hits itself, -1, or it hits the boundary, which is cell value 2, or an object within the gameplay area, which is 3, then the game is over. So we can see with the code we're saying snake, boundary, object. Now if it's any of those, we set our boolean on and off for our main game loop. We switch that off. Next, we remove the tail of the snake to show that the snake moved. We remove the head of the snake so it doesn't overwrite the borders or the objects. We can see that if the head of the snake was here, then we would turn that to -1, and so that would be green, and that would spoil the border. And likewise, if we turn an object to -1, then that would turn it green, and that would spoil the border. So we don't want to show that, but we just want to show where the snake collided. So that would be -1, and that would still stay 3. And likewise here, this would be this is -1, and this would say 2, and it would show that the snake is up against the border. The next thing we do is we show a game over message. We also test whether the user has met a high score. Now, high score is a function. We test to see if the current score is a high score, and we update the GUI with the score. So we take high score, the current score, the high score, and then we test them against each other, and then we update the high score accordingly, and we return a value, true or false, to the calling argument. We call the function high score, and if it's true, if it returns true, we create a message that says you're dead, you have set a new high score. If the message returns false, then it creates the message you're dead, and at the end of this process we show the message box with whichever message is created here with the game over title, and that's how we notify that the game is over. Case 1 is the mouse. If the object that the snake is to move into has a value of 1, then we know that's the snake. So what we do here is we increase the score by the game level. So when we're on level 1, the score increments by 1. When we're on level 2, the score increments by 2. When we're on level 3, the score increments by 3. So our score is dependent on the level in which we're in. Then we show score, and we can see here that we update the worksheet snake range, named range end score, and score equals the global variable int score, which we updated earlier. In this case, the snake captures the mouse 10 times before leveling up, and this is where we test. If mouse counter is less than 10, then mouse counter equals mouse counter plus 1. We set our collection, the head of the snake, and we give it a value of -1, and that changes its color to the snake color. Next we go to show mouse, which will be on the random show. If I just click it to procedure view and click to show mouse, and we can see here that this sets a random cell reference for the mouse, checks to ensure it does not appear on any objects such as a mouse or obstacles, sets the cell value to 1 to show the mouse. So what we do here is we set this range via a function ftn random placement, and once we found a valid range, then we give it a value of 1, and that shows that cell as the mouse cell. Here the control for the loop is that the range that we find has to be empty. If the range has a -1, a 2 or a 3, then we have to find another range, and so this iterates over and over again until it finds a range that has no value in it, and it sets that value to 1. ftn random placement. And this is where we define our boundaries of the game, and we set our random column and random row. So here we're setting the boundary of the game area. Top left 8, top 6, right 81, bottom 42. We return the cells that we randomly found. Once we've caught a mouse, we need to grow the snake, and that's the amount of elements the snake grows is defined by the user on the user interface. So grow snake calculates the number of segments to grow the snake, grow the rate from the GUI converted to a percentage. We have a variable here, double growth, and double growth is worksheet snake range n growth, so that's the name range, divided by 100. So we take whatever value is in the user interface and we divide it by 100 to get its percentage points. We update the variable int growth by taking the collection count of elements, that is the snake elements. Don't forget that we're using the collection to control our snake. We take the collection count, so it's the number of elements within the collection. We times that by the percentage on the user interface, and we return that as an integer. So our growth is a percentage. So that's grow snake. The next thing we do is we calculate the acceleration. And this note here says get acceleration from GUI and convert to inverse value, then to a percentage for the new snake speed. This uses the global variable double timer value. We adjust the value of double timer value. We collect the double timer value, take the number from the GUI that the user has entered as a parameter for acceleration. We take that away from 100 to give ourselves a value, and then we convert that to a percentage. And then we times double timer value by that percentage, and that gives us our new speed. If we have a look at that calculation, we can see from the GUI that 0.2 is the speed and acceleration is 1. Here's sheet 1 where I've got the calculation. You can see speed is 2 and acceleration is 1. And that's, it says here, start speed, acceleration is a percentage. But it's not shown as a percentage, just as a whole number, so we need to do a conversion. So we say double timer equals speed. The first part of the calculation is 100 minus the acceleration number, and in this case we can say 100 minus d5, which is this number here, d5. Actually, it might be easier to see it this way, 100 minus d5, which is 100 minus the acceleration, which gives us a value of 99, a whole number. Then we convert that whole number with this calculation, full calculation here, into a percentage. So effectively we just divide our number here by 100, our 99 by 100 to give ourselves a percentage, and then finally we times our timer by our percentage to give ourselves our new speed, and we apply that to a double timer value, and we can see here that we've got 0.2 times by 0.99, and this gives us our new speed. Now new speed is a little bit faster than the original speed. If we were to increase that to say to 0, we would see that our speed increases a bit faster, so 0.16 instead of 0.19. And that's how that calculation works to increase the speed. This section deals with mouse capture. When we've captured a mouse less than 10, and 10 is our threshold for leveling up. The else section of the if statement deals with leveling up, creating a new level. Leveling up resets snake speed to that of the GUI. First off, we show the notification, and we say the notification is true. We've got show notification, and we can see here show notification is a simple sub procedure. Shows the user notifications for the start of a level. So worksheet snake looks at the shapes and it finds SHP notification, and it just shows its visibility. So its visibility is bshow, which is a Boolean value, and bshow is a parameter of this sub procedure, and we set that to true when we called it. So we can see here we called it show notification and our parameter value was true. Now we go on to set the game timer value, and the game timer value, as we've seen before, game timer takes a double value for speed, and this takes the value from snake range end speed. We can see on our GUI end speed is 0.2, so we reset it to 0.2. Now we call new level sub procedure. New level. A new level sub procedure has a number of calls in there. So we reset the global variable int mouse counter to 1, and this counts the number of times the mouse has been captured, so we're resetting that. We call game level counter for user game level to be shown. First off, we test if game level exists, so we have a function here. ftn game level exists. This tests if a game map exists, looks at number, looks at named ranges on the game worksheet. If we go over to our workbook, Games tab, and in the Games tab, we have several game level maps. And each game level map is given a named range. So game 1, end game 1, we can see that's highlighted there. End game 2, that's highlighted here. End game 3, that's highlighted here. So each game level is given a named range. The format of that named range is end game plus its number. Going back to our function, we update the int temp variable, and that's int game level plus 1. And as we saw earlier, int game level carries the number of what level we're at any one time. Next, we run a for each loop, and in this case, it's for each var name in names. So that's every named range in the named ranges. If var name refers to range parent name games, that's the worksheet. Here we test what the game number is. So we remove characters end game, and we see whatever value is left after that. And that value we test against the int temp. And the int temp, as we know, is the current game level plus 1. If that exists, this function returns true. If it does not exist, then this function returns false. And all this is really doing is just trying to find what the next game level is. When we come to the last game level, we just stay on that last game level. That's how we choose the game levels. We start off on game level 1. When we capture 10 mice, we move to game level 2, and so on until we get to the last game level. And once we reach the last game level, we keep replaying that last game level. And that's how it's been designed. Game level calls, does the game exist, true or false? If it's true, then we increase the game level by 1 to choose the next game screen. We update the user interface and we show the user what game level they're on next. The next call is show game level. Show game level is copy and paste game map into the gameplay area. We apply to the variable string game to copy end game and whatever the game level is that we've chosen from int game level from the previous process. Next, we choose the game from the game sheet, which is through this variable string game to copy, which we created here. We copy that, and then we go to range end game paste, and we paste our game. So looking at our game screen, let's say we copy end game 3. This gets copied. Go over to snake, end game paste, which is a named range, and then we paste our new game map onto this screen. And that's how we update the game level. Finally, we just hide the cursor from view and we hide it behind the new game button. We show notification with a value true, and we saw that earlier. We set the game timer, and we saw how that is done earlier. Next, we switch off the notification to the user, and we initialize snake. Ensure the snake does not appear in the same place on rebirth. We call random show snake, and this is similar to random show mouse module random show. If I just random show snake, and we can see here sets the random cell reference for the regenerated snake, checks to ensure it does not appear on any objects such as mouse or obstacles. This calls the same function random placement that we used for the mouse, and it sets it inside this loop. So what we're saying is give us a random cell placement and we'll test whether that cell is empty. If that cell is empty, then we're going to use that cell to generate the snake. And next, we set the row value from the range and the column value from the range. And R and C are global variables. Ensure the mouse does not appear in the same place on rebirth. And then we call show mouse again. And we've already seen earlier how show mouse works in a very similar way to random show snake. Here we see the notes. Initially grow the snake by 2 segments to equal 3 segment snake. We update the global variable int growth to 2. And int growth we can see is generally updated by the user. Int growth is updated by the user on the GUI, but we're going to override that. We set int growth to 2, so it grows the snake from 1 segment to 3 segments in total. We get the speed from the user. This is via double timer. We pick this up from the GUI and from the named range end speed that we've seen earlier. Our next notes clears all the elements of the collection ready for new updates and additions. We set the collection to nothing, and that clears all the elements within the collection ready for new updates and additions. The collection helps us manage the snake. When we grow the snake, we add a segment as a collection item. Each segment we add, it becomes a new collection item. When we move the snake, we add a new collection item and we give it a position. Next, we need to add segments to the collection, and this is done using cells row column address. So we add the address of the segment to the collection. Once we've added our segments to the collection, then we have to draw the snake on screen. We draw the snake on screen by giving the cell value -1, and conditional formatting converts this into a cell color that represents a snake. And here we apply that -1 to the segment. So in this case, collection element 1, which is a range, is given the value -1. Set the starting movement of the snake. Now, we didn't want the snake to always appear in the same place, so we had random show snake. But we also don't want the snake to be predictable in as far as its movement and direction of movement is concerned. So what we do is call random direction, and this is where we determine the direction of the snake. This will be in our module random show. We select random direction, and we can see in the comments, used when the snake is regenerated on the screen, randomly selects the snake direction by setting the global variable string direction. Here we define our array, and our array has characters U, D, R and L, and that represents the onKeys movements. We select randomly from that array. That is what we do here using the RND, the rand function. We're randomly selecting U, D, R or L. And finally, we apply that random selection to the global variable string direction. And that's how the application knows which direction to send the snake when it first reappears. That's the process for initialize snake. Finally, we call gameplay. Gameplay gets set again. So off we go with gameplay, and the whole cycle starts all over again. So we fall back down to our game loop, and we call move snake, which we've just been looking at, and game timer, which creates the animation. After we've tested the game is over, and then tested that we've captured a mouse, all that's left is case else in the select case, and case else is the snake movement. This means the game is not over and we haven't caught a mouse, so we just have snake movement. That's this next section. We set the range for a new element of the snake, a new segment of the snake. We give that cell the value of -1. We take the range from the back of the snake and we give that cell value of nothing, an empty double quotes, and that shows the snake has moved one segment for the head, a -1 segment for the tail, and that gives the impression of moving. The other thing we test for is growth. If you remember earlier, we updated the global variable int growth. Now int growth tells us how much we're going to grow, and we get that from the user interface. Here we say if int growth is greater than 0, then int growth is int growth -1, so we're reducing the count of int growth. Else, if int growth is 0, we remove segment 1 from the collection. So this has the effect of the snake growing. So when we move the snake, it increments by 1 segment. If we have a value in int growth, then we do not remove the end of the snake. But if there is no value in int growth, then we remove the tail from the snake. So visually, this has the effect of the snake head being increased by 1, but the tail not reducing. So it looks as though the snake grows from the head onwards after it's eaten a mouse. Normal movement is the head grows by 1, the tail shrinks by 1 segment. And that's how we give the impression of the snake moving. And that is the move snake subroutine. Here we've left the beginning of the game to the end, so to speak. The initialization of the game, the main entry point, is snake main. So if we isolate that in the code, snake main is initiated by the new game button on the user interface. The first thing we do is we declare onKeys. As we saw earlier, declare onKeys is in module onKeys, MDR onKeys, and we can see declare keys, and this is where we declare the behavior. of the arrow keys. That's initialized at the very beginning of the game. Next, we update the variable int game level to 0, int score to 0, and then we call show score, and we saw that earlier on. Show score, all we do is we take the worksheet snake, the range end score, and we update it with int score. We can see previously we added the value 0 to int score. New level we went through earlier, and this is where we set the mouse counter game level, we show the game level, we show a notification to the user, and we set the game timer. We make the show notification invisible, we initialize the snake, and then we start playing the game. All the while the game is being played, this is through new level. We keep going until we get to the end of the game, till we get to game over. And at the point that we get to game over, we then come back to this calling procedure, the main snake procedure, and we reset onKeys. As discussed earlier with onKeys, the default behavior needs to be reset. So that's how we initialize a game, that's how we start the game. If we have a look at the declarations, we can see we have a number of global variables. So we got R and C, that represents the row and column, and we use that to move the snake around and manage the snake. And then we have int game level, and that's how we show the game maps and also to increment the score. String direction is a direction of travel, and this is how we move the snake around, and we use that in combination with the onKeys. So the onKeys updates this global variable string direction. These variables are private to the module snake and the module snake only, as opposed to the global variables which are available to all modules within this workbook. We have int growth, and that's the growth counter, int score, and that's our score which we update, int mouse counter, so we know how many times the mouse has been captured, and we have collection as a new collection. We create a collection which we fill up with cell addresses, and in each one of those cell addresses we give a value of -1, and they show the snake. What we do is we add to the collection, which adds an element at the bottom of the collection, and that is a snake head. And then we remove an element from the collection, and we remove the first element, and that's the snake tail. And that's how we show the movement. So at any one time, when we show the snake, we have a collection that represents all the snake coordinates, that is their cell addresses, and that's how we manage the snake. If we have a look at all our procedures within the module snake, we can see the only one that we haven't dealt with is clear snake. We've dealt with function game level exists, function high score, game level grow snake, initialize snake, move snake new level, show game level, show notification, show score, snake main, and that's the one we've just discussed now. Now clear snake, this was used in development, and this helped me remove the snake from the game area whilst I was developing the game. It's no longer used, but I've left it there just in case I wish to do more development and wish to use this again. All we do is we go through each element within the collection and set its value to an empty string, and that removes the address. Now if we have a look at the other modules, we'll have a start at the top, module onKeys, all the procedures within here, declare onKeys, press down, press left, press right, press up, reset onKeys. We've been through all these. Random show, the elements within here, function random placement, random direction, random show snake, show mouse. We've been through all these. Module timer key state. Now this has its own set of variables, 2 global variables in the declaration here. We have a global variable be on off as a boolean, and that controls our main game loop in gameplay. When it's set to true, the loop will continue to run. When it's set to false, the loop will stop running. That means the animation of the game will stop. We also have double timer value, and that controls the speed of the game, and we update that from various places within the game too. Next in the declarations is the public declare function, get async key state lib user 32. This is used solely within Microsoft. It's a Windows library, and we use it to listen out for the user key presses whilst the game is running. The procedures within this model are gameplay and game timer, which we've been through. So we've been through all the procedures within all the modules. We've also looked at this workbook. This workbook, before close, is we call reset onKeys, and this is just in case the game hasn't completed properly. Reset onKeys is called as a safety measure, just in case the game hasn't completed and reset the onKeys as part of gameplay. We reset the onKeys just before we close this workbook. And that is the snake game. That's the coding behind it.